Is China getting that good at robotics? Why are the giants panicking? Can you believe it? Jim Farley, the CEO who helms Ford Motor Company, was restless after just 3 days of inspecting Chinese factories. In a conference call with Wall Street analysts, the CEO, who earns over $20 million annually, dropped a bombshell in front of global investors. We've been thrown into the background by China. The gap is more terrifying than imagined. On the other side, Andrew Forrest, the chairman of Australian mining giant Fortescue Metals Group, was even more resolute. The day after returning home, he halted a self-developed electric vehicle powertrain project that had been invested with tens of billions of Australian dollars, stating publicly that any further investment is just burning money. Why did this group of Western tycoons, who control multi-billion-dollar empires and have witnessed countless industry storms, collectively break down after touring Chinese factories? You must know that they used to equate made in China with cheap contract manufacturing. But after this trip, the ingrained impression of Chinese manufacturing being backward was completely shattered. What kind of factories did they enter that could make such seasoned business veterans lose their composure? The mystery is not complicated. China's dark factories have turned manufacturing into a fully automated game. You can imagine the factory as a super robot. AI is the brain, responsible for calculating production plans and preventing failures. Robots are the hands and feet, tightening screws and welding car bodies with more precision than old technicians. And the Internet of Things, IoT, is the nervous system, with the location of all materials from raw components to finished goods under control. The entire process runs without lights, without human monitoring, and the machines flawlessly complete the work on their own. What's even more disruptive is that these factories not only work with high precision but have also evolved the ability for autonomous thinking. They don't just follow a dead program. They figure out how to work based on the actual situation. Greg Jackson, the head of Octopus Energy in the UK, stared at the screen for 10 minutes in a factory built by Foxconn Industrial Internet and Tencent in Shenzhen. An AI vision system scanned a 20 cents \text dollar scratch on a mobile phone casing, 1/5 the width of a human hair, and accurately marked it 100 times faster than an old quality inspector's eyes, with 0 errors. The Neo car body workshop is even more uncanny. The AI holds the welding gun like an old Chinese medicine doctor taking a pulse. Sensor data on temperature and pressure are transmitted in real time. Combining this with 10 years of historical data, the AI instantaneously adjusts the welding path and the robot arm's force. It perfectly handles the welding differences between steel batches that even master technicians struggle with. Crucially, 80% of these production decisions previously required a 30-minute meeting among workshop supervisors. Now, the AI makes the call in milliseconds, with no error rate. This thinking factory has completely shattered the Western notion that automation equals mechanical repetition. This is no longer machines replacing people. It's machines surpassing human experience and judgment. What these Western executives saw was not a production line but a relentless, continuously evolving superworker. The shock delivered by this technological gap is far more unsettling than any statistic. The shock felt by these Western executives is just the tip of the iceberg of China's robotics revolution. Next, we will fully examine how exactly has China become so adept at robotics. What are the secrets hidden in the Sino-US EU smart manufacturing rivalry? And what does this revolution mean for each of us? China's robotics revolution, policy, scale, and efficiency. The scary journey of Western tycoons was foreshadowed by data. When Ford's CEO lamented being left behind, he might not have closely checked the latest report from the International Federation of Robotics. China installed nearly 300,000 new industrial robots in 2024, more than the rest of the world combined, and 10 times that of the US. More disheartening is the robot density, the number of robots per 10,000 workers. China's density increased 19-fold in 10 years, reaching 470 units in 2023, leaving the US 295 units, and Germany 429 units, behind. These figures did not appear out of thin air. The all-robot assembly that Australia's Forrest witnessed in the factory is a daily reality in China's machines replacing humans wave. From the Made in China 2025 strategy to the 14th Five-Year Plan for Robotics, the government has treated robotics as a strategic industry, offering tax breaks and subsidies. Furthermore, the aging population provides a push. Companies cannot lower costs without adopting robots. In contrast, Silicon Valley capital focuses on fast money, like software. Boston Dynamics robots may be able to dance, but their commercialization is slow. This inertia of prioritizing bits over atoms has made them a step slow in hardware implementation. China's advantage is its ability to twist political determination and market demand into a single force, rapidly converting laboratory technology into assembly line productivity. The Sino-US smart manufacturing rivalry, brain versus body. The smart manufacturing rivalry between China and the US has long been a contest between the brain and the hands and feet. The US holds the AI software trump card. OpenAI's large models and NVIDIA's computing chips support the intelligent brain of robots. Tesla's Optimus robot can hold smooth conversations thanks to this capability. But when it comes to building the body, their shortcomings are exposed. An Optimus robot costs $50,000 to $60,000 USD to produce, while a similar robot from China's Unitree Robotics costs only $16,000 US, a price difference of nearly 3 times. The core of this gap is the industrial chain. China is the only country in the world with a complete set of industrial categories. From the chip to the shell of a robot, everything can be manufactured domestically without external dependence, naturally keeping costs low. The US, however, must rely on the global supply chain, causing disruptions when a critical component is constrained. The US is now anxious, launching the Genesis Project, comparable to the Manhattan Project, aiming to integrate resources through state power. Still, compared to China's model of concentrating resources on major tasks, their market-driven approach remains too fragmented. For example, China is promoting Sino-US to standardize robot software and hardware, similar to Android unifying mobile phone operating systems. This level of top-down design is difficult for US companies to achieve spontaneously. This contest shows that smart manufacturing competition is not about single breakthroughs, but a comprehensive test of the strength of the entire industrial chain. Europe's anxiety and China's market for technology. Strategy. Germany, the star student of Europe, is also showing anxiety in this revolution. As the originator of Industry 4.0, Germany invests €5 billion annually in robotics R&D, and its robot density was once a global benchmark. But in 2024, they found that the market share of local Chinese robot manufacturers has surged to 57%, and Germany's KUKA Robotics is having an increasingly difficult time in the Chinese market. More crucial is talent. Germany has long cooperated with KUKA to build robotics labs, where vocational school students directly operate real equipment to learn skills, cultivating a new blue-collar workforce that understands both programming and machinery. This precisely hits the US pain point. Silicon Valley talent flocks to software, with few willing to focus on hardware technology. Meanwhile, China trains engineers through school enterprise cooperation, while millions of workers accumulate experience on production lines. The lesson from Europe is clear. Smart manufacturing upgrades require not just technology, but also a supporting talent system. China's current challenge is its reliance on imports for core components, like high-end reducers and servo motors. Still, our advantage lies in the exchange market for technology. Strategy. With so many robots running on production lines every year, we will eventually perfect our own core technologies. Today's Germany serves as a valuable lesson for China. Only by tightly weaving together technology, talent, and industry can we avoid falling behind. This robotics revolution has long jumped beyond the factory walls and become a ballast stone for national strategy. The US military is pursuing the Replicator Initiative to create thousands of cheap autonomous robots to counter conflicts. At China's 9.3 military parade, an integrated killing network composed of unmanned combat vehicles and drones was unveiled, signaling a shift in military thinking from powerful individual weapons to strong overall systems. The logic behind this is simple. Whoever controls advanced robotics technology controls the future industrial chain and security initiative. For China, robotics is not just a production tool but a supply chain security lock. No matter how the international situation changes, the robots in the dark factories will not stop working, firmly safeguarding the foundation of our manufacturing industry. The West's fear is essentially discomfort with the rules being rewritten. They used to dictate the rules through technological monopoly. Now, China is transforming Made in China into Smart Made in China, with its advantages in scale and full industrial chain. But this is not a zero-sum game. As the founder of A16Z said, this is a new global arms race. But it is a race in the speed of technological progress, not weapons. China's goal has never been to surpass anyone, but to establish a firm foothold in the global industrial chain through its own strength. The shock of Western executives is, in fact, a wake-up call for global technological competition. The rise of China's robotics industry is not due to luck but the result of the combined efforts of policy, market, and talent. We have the advantage of a complete industrial chain, and we are clearly aware of our shortcomings in core components and basic algorithms. In this revolution, there are no eternal winners, only continuous forward movers. For you and me, this is not distant industrial news but a nearby opportunity. Those studying programming can join robot software development. Those in technology can participate in core component breakthroughs. Even ordinary workers, by learning to collaborate with robots, can become the new blue-collar workforce. Where is the next breakthrough point for China's smart manufacturing? Do you think we should first conquer core components or optimize AI algorithms?